Hello everyone, this is Sairaj from AML and my tech talk topic is geometric decision tree. Introduction. Decision tree has proved to be value tool for the description, classification and generalization of data. Work on construction decision tree from data existing in multiple disciplines such as statistics, pattern recognition, decision theory, signal processing, machine learning and artificial neural networks. We propose use an adaptive boosting method for boosting decision tree, which will create multiple small geometric decision trees in the view of improving the performance of prediction in terms of accuracy, convection, matrix precision, and recall. This proposed modification to geometric decision tree is applied on standard data sets from UCI repository. Advanced in data collection methods, storage and processing technologies are providing a unique challenge and opportunity for automated data exploration techniques. Enormous amount of data are being collected daily from major scientists projects. Example, Human Genome Project, the Hubble Telescope, Geographical Information System, from stocks trading, from hospital information systems, from the computerized scales records and other sources. A decision tree can be used for data exploration in one or more of the following ways. Description. To reduce the volume of data by transforming it into a name compact from which preserves the essential characteristics and provides an accurate summary. Classification. Discovering whether the data contains well separated classes of objects such that the classes can be interpreted meaningfully in the context of a substantive theory. Generalization. Uncovering a mapping from independent to dependent variables that is useful for predicting the values of the dependent variables in the future. Automatic construction of rules in the form of decision trees can has been attempted virtually in all discipline in which data exploration method can have been developed. Terminology. Structures similar to decision trees have been called classification tree, branched testing, sequence discriminant trees, and identification keys. Training set consists of objects also known as samples, observations, examples, or instances. Attributes have been referred to as features, predictors, or independent variables. In an order attribute space, a decision tree imposes a partitioning that can be geometrically represented as a collection of hypersurface and regions. Much of the work on decision trees use only a specific type of surface, namely hyperplanes. For this reason, splits are often referred to as hyperplanes, attributes as dimensions, and objects as points. Category or dependent variables is the same as class labels. Ordered domains are equivalent to or comprise continuous integers, real valued, and monotonous domains. Unordered domains have been categorically discrete or free variables. Internal nodes are the same as non-terminal or test nodes. Leaf nodes are referred to as the terminal nodes or decision nodes. Goodness measures are also known as feature evaluation criteria, feature selection criteria, impurity measures, or splitting rules. Geometric decision tree. The performance of any top-down call tree algorithmic rule depends on the live accumulated rate, totally different hyperplanes at every node. The problem of getting an appropriate algorithm rule to search out the hyperplanes that optimize the chosen rating performance is additionally necessary. As an example, for all impurity measures, the optimization is tough as a result of finding the gradient of the impurity performance with the relation to the parameters of the hyperplanes isn't donable. Driven by this concern, here we have a tendency to propose a replacement criterion performed to assess the suitableness of a hyperplane at a node which capture the geometric structure of the category regions. For our criteria performance, the optimization downside also can be solved additional simply. We have a tendency to initialize make a case for our technique by considering a two-class downside. Given the set of coaching patterns at a node, we have a tendency to realize to hyperplane that is one of the every category. Every hyperplane is specified its nearest to all or any patterns of one category and it is farthest from all patterns of the opposite category. The decision these hyperplanes because the clump hyperplanes for these two classes. Thanks to manner there outlined, these clamps hyperplanes capture the dominant linear tendency within the sample of every category that are helpful for discriminating between the categories. Hence, a hyperplane that passes in between them may be sensible for rendering the feature house. Thus, we have a tendency to take the hyperplanes that bisect the angle between the clump hyperplanes because this splitting rules at this node. Since in general there would be two angle bisects, we elect the bisect that higher supported associate impurity that is Gina index. If the two clump hyperplanes happens to be parallel to every different, then we have a tendency to take a hyperplane midway between the two because the split rule. As are often seen, thought it hyperplanes promotes the purity of kids nodes. It doesn't every alter the classification downside. It doesn't capture the isobilateral distribution of sophistication regions during this problem. The two are the clamp hyperplanes for the two categories and also the two angle bisector obtained through our algorithmic rule at the foundation nodes on this downside. As are often seen, selecting any of the angle bisector because the hyperplanes at the foundation node to separate the info. Let us understand this by one example. Consider the 2D classification problem that is shown in figure, where the two classes are not linear separable. The hyperplanes land at the root node using OC1, which is an oblique decision tree algorithm that uses the impurity measure of Gini index is shown in figure 1a. As can be seen, although this hyperplane promotes the impurity of child nodes, it does not really simply the classification problem. It does not capture the symmetric distribution of class region in this problem. Figure 1b shows the two clustering hyperplanes for the two classes and the two angle bisector obtained through our algorithm at the root node on this problem. As can be seen, choosing any of the angle bisector as the hyperplane at the root node to split the data results into linear separable classification problem at both child nodes. Thus, we see here that our idea of using angle bisector of two clustering hyperplanes actually captures the right geometry of the classification problem. This is the reason we call our approach geometric decision tree. Here you can see this is the figure 1a, figure 1b, example to illustrate the proposed decision tree algorithm. This indicates the hyperplane land at the root node using an algorithm OC1 that relies on impurity measure of Gini index and angle bisector, the clustering hyperplane at the root node on this problem, which will were obtained using our method. This is by using the OC1. This is by using the bisect angle bisector hyperplanes. In this, we will use the AdaBoost algorithm. So build distribution D1, assuming all sample equally important. For T1 equal to 1 to T, a round of boosting group check if in error larger than 1 by 2. Yes, terminate. No, if it is error larger than 1 by 2, terminate. If not, go on. Calculate confidence parameter weights on subclassifier. Here given 8 equal to 1 by 2 of ln of 1 minus T by summation of T greater than or equal to 0. We weight that data sample to given poorly classified samples and increased weight. dt plus 1 equal to dt by zt, that is where e minus at if yi equal to st of xi, e power at if yi not equal to st of xi, where is the normalization factor at the end. At the end, TTH round, the final storage classifier results H final x equal to sigma of ATHT of x. Conclusion. Geometric decision tree has a new algorithm for acquiring oblique decision tree. The original is learning hyperplanes that capture the geometric captures of the class regions. At each node, we have established the two clustering hyperplanes and selected one of an angle bisector as the split rule. Based on information game, we argued that our method of choosing hyperplanes at every node is sound. Through wide experiential studies, we mentioned that method performs enhanced than the other decision tree approaches in terms of accuracy, space of the tree, and time. It also exposed that the classifier obtained with geometric decision tree is as good quality as that with SVM, whereas it is quicker than SVM. Thus, overall, the algorithm represents here is an excellent and narrative classification method. Thank you.